Before we start having a little fun with GLBP and messing around with the AVG selection a little bit, I did want to show you the second half of the information under Show GLBP that deals primarily with the AVFs. And it's really showing the same information we saw under Brief, or at least verifying that. You can see at the very top, this is the line that tends to throw people the first time they see it. There are 3 forwarders, but 1 is active. And the first time you see that, you think, well, what's wrong with the other 2? Well, their state is listen, and we know what that means now. It's just listening in. Again, the forwarder where the state is shown as active, that's always going to be the local router, the one you're actually on. This one shows you the virtual MAC address of that forwarder and default there. And then the owner ID is the real MAC address of that particular router. Forwarder 2, state is listen. Here's the MAC address that was learnt. Just something funny about that. I haven't heard learnt in a long time. Learned, however it got there, it's there. And here's the active router for forwarder 2, which is 172.16.23.2. That's our router 2. And then forwarder 3, status listen. Here's the learnt virtual MAC address. Here's the actual MAC address. And here is the IP address for the router that's active for that forwarder, which is router 1. So we know now that with our AVG selection, the AVG is pretty busy. It's got a pretty good workload. So maybe we want to change the default selection of the AVG a bit. Because right now we have 3 routers and it's the priority that deals with the AVG selection. We know the default priority is 100 and we haven't done any changing of that default. So router 3 was chosen as the AVG strictly because it has a higher IP address on it than the other 2. So let's say we want to change that. We want router 2 to become our AVG. What I'm going to go do is simply just change the priority. I already have preemption on there, so theory holds that when I do this, everything else should fall into place pretty quickly. So let's see if the theory is right. We've got preempt, priority is what I wanted. And this one's 1 to 255. I'll set it to 150. And that's it. No options, no nothing. And we get a state change, group 1 state standby to active almost immediately. Let's see if we get any others before we start running our show commands. Doesn't look that way. Let's run show GLBP. And let's see, state is active. We've had a state change. We're up to 2 state changes. Everything else is the same, but we're on router 2 now, and notice that active is local. The standby is now router 3. That's the big change. Everything else there except priority, of course. Let me show you where you verify your priority change. It's right there in the middle of all of that. Priority 150 configured. If we run the brief option, then you can see there's been a change there. We're on router 2 again. Here's the information we know about the AVG. The AVG has a priority of 150 and it's active, which means we're on it. And there's the virtual IP address. The active router is local and the standby now is 172.16.23.3. So that standby seems to be kind of a formal situation, a formal role that we want to fill. So let's say that we want 2 to be our primary AVG. We want router 1 to be the standby AVG, and then we want 3 just to kind of hang around. So we would need to do what there? What's the logical thing we would do? Go to router 1 and give it a priority between 100 and 150. So it has the second highest priority in our group. So let's go ahead and make that happen. And we have preemption on that one. We should have preemption on all of them enabled. So there's our change of priority. I haven't seen anything yet. Let's run show GLBP brief. And you can see it did indeed take the role. We didn't see a console message, but show GLBP brief. Here's the information on it. Forward, priority of 125, state standby. So we are on the standby router. We know that right now. There's the address of the virtual router. There's the active router, and there's one more reminder that we're actually on the standby. It's local, and that's it. So it's really just that simple. Just make sure you have preemption enabled when you're doing that. Now, so the theory holds right now. Router 2 is our primary. Router 1 is our standby SVG. And then router 3 is just kind of hanging around. It's no longer taking any of those roles. So let's go ahead then and take router 2 offline and see what happens. Oops. Let's try that again. There we go. Switch 2. And this is the quickest way I know to do it. And you get a couple of state changes immediately. And we've got a line protocol down. Let's go over to 1. And you can see already the change has taken effect because here's our line indicating we're talking about the AVG. Switch 1 still has a priority of 125, but now look at this, it's active, which means it's the primary AVG. There's the IP address of the virtual router. The active router is local, and the standby router is unknown, but very shortly that's going to come up as router 3. That does take a little bit of time. And there, in that brief time I was telling you that it took a little bit of time, it happened. You can see now with router 2 out of the picture, router 1's taken over as the AVG, and router 3 has stepped into the standby role. Now finally, before we move on to something else, let us take router 2 and get it back online. And as it comes back up, we see a message, of course, about the line protocol. Let's wait and see if we see any GLBP messages come up. There is a state change from speak to active. Looks like a couple of forwarders have gone from listen to active. So let's skip over to 1. See what we can see. It's still listed as the local, router 1. So let's give that a moment to cook, so to speak. So not always the fastest converging protocol. There we go. There's a state change from active to speak. Let's see what we have here now. And you can see that that cutover has concluded. And we are on router 1. The priority is 125. It's in speak, so I believe that's going to go to standby in a moment. There's the address. The active router is 172.16.23.2. 3 is still shown as the standby. So let's run it one more time, and now you can see the convergence is complete. I'm glad that's happening because I want you to see it, because we get so used to things converging, you know, like that in half a second, that when it doesn't happen, we think something's broken. But it's not broken. It just took a little longer to work. There's the line indicating the AVG. The priority of switch 1 is still 125. Now it's back in the standby role. There's the active router, 23.2. We know that's the AVG, the primary, and the standby is the local. So that's how we use the primary to be deterministic, not just about our primary AVG, but also about the standby and how to verify it with show GLBP brief. So we are going to stop this lab here, and in the next one I believe we're going to head to those timers, because we had 2 timers, not to begin with 2 timers, we have 2 GLBP timers that we're certainly familiar with, hello and hold time. We've got those down cold, and they do the same thing here than they do in HSRP. But those other 2 timers were a lot different, and they're very important, so we're going to take a look at those in the very next lab. I'll see you there.